and we will get basically the local change between the two. So I'm going to create a variable called rot for now, and that's going to hold the whole rotation value. And I'm going to, inside of brackets, say $Bono7 dot transform multiplied, and you have to multiply it by the inverse of the other transform. So inverse So we're going to multiply this bone by the inverse of this helper object. Oops, I forgot my equal sign. So rot is going to equal this. And I'm just going to say print rot. And I'm going to open the listener and hit evaluate. What it's done now is actually it's printed out the information that's now stored in the variable called rot. This is a matrix, and what we're looking for is a rotation. In actual fact, we're looking for an Euler rotation. So the next step I'm going to say is dot rotation. So this will get the rotation part out of the transform that we're calculating inside those brackets. Hit evaluate, and you can see that I'm now getting a quaternion value. It's basically a zeroed out quaternion value. Still not what we want, because we need an Euler value, an XYZ value. To do that, I'm going to say as Euler angles after it. So as Euler angles, if you check in the help file, will convert a quaternion into an Euler value. Press evaluate again, and now you see the Euler angles. We've got these very small exponents, it looks like. So essentially that's 0, 0, 0. It's very close. To get the x value, we'll go, just say in this case, print rot dot x. And there's the x value for it. So what we can do now is we can use this to drive the x rotation. I'm going to delete the 0 now and delete the print statement, and we're just going to use the value that's here. So I'm going to say evaluate. Pick my bone, and I'm going to put a fin on it, just so again we can see what's happening to it. Pick my elbow control, and you can watch as the elbow moves up and down. You can see the bone rotating wildly. This is because we're pulling an angle value, and Max's rotations are based on radians. So we need to convert this value to a radian now. So Deg2 rad will convert this value to a radian. Press evaluate, try it again. Now you can notice what's actually happening is it's essentially just rotating double the amount of the upper arm bone. We need it to rotate in an opposite direction. So I'm going to say deg2 rad minus rot x, evaluate. Now you can see that that twist bone is staying aligned essentially off to the top of the shoulder. So it's rotating in an opposite direction. So as a quick breakdown again, the depends on statement makes it dependent and actually work in real time. If I remove this depends on statement, you'll notice that I'm not getting any real-time feedback. I would only get feedback if I animated this and scrubbed the time slider. The equation is simply I'm creating a variable. I'm multiplying the inverse of the upper arm bone, the transform of the upper arm bone with the inverse transform of this point helper that's been aligned to it. Asking for the rotation part of it, converting it to an Euler angle, converting it to degrees to radians, inverting it, and then looking for the x value out of it. Sounds a little complicated, but in practice it's actually relatively straightforward. I want to point out a couple of problems right off the bat with this and show you where this can fall apart on you. First part being is if I change